Hello, welcome to ASNU. Today we're looking at the ASNU remote control software to precisely control injectors and generate injector data, such as dead time. The standard ASNU machine always drives the injectors at 13.8 volts and a fixed current, and it has a limited number of presets for pulse width, engine speed, duty cycle, and flow test time. Combined with the optional variable voltage power supply, the remote control software allows you to set your own injector voltage and current and an infinite range of pulse widths, engine RPMs, duty cycles, and flow test times. When you launch the program, you'll see the ASNU website page, and you can select various other screens along the top here. Down the bottom is a message box, and this is where any errors or status messages will be displayed. These can be cleared at any time using the OK button. In my case, the error will reappear because I don't have a machine connected. For general help, click on the Help tab and select the user manual. To configure the program, select the Config tab. This has already been covered in a separate video. To test injectors, select the testing screen. This is where you'll find additional screens for testing. First of all, we have the injector current screen. This allows you to drive the injector with exactly the same current as the engine ECU. In this case, we are driving the injector with 2 amps for the whole pulse width. For peak and hold injectors, you can change the peak and hold currents. So in this example, we've got 4 amps peak current and 1 amp hold current. The peak current is turned on for 1 milliseconds, and that can be changed as well. GDI injectors require an initial kick to get them open, a very high current, and this can be set here. So in this case, we'll get an initial kick of 8 amps for 0.1 milliseconds. If you're not sure, you can use these 3 presets, which will cover most situations. Okay, so I'm going to select port saturated, which is going to give us 2 amps maximum for the whole of the pulse width. If the injector resistance is high, it may only take 1 amp of this maximum. This maximum is in effect a current limit. While using the remote control program, I recommend you leave the machine on the home screen. Now let's move on to the test settings screen. This is where we define the voltage pulse to the injector and the type of test we want to run. In this case, we've got a 13.8 volt pulse to the injector for 2.5 milliseconds every 20 milliseconds. The cylinders defines the number of injectors we're going to flow test, and if we have the optional variable voltage power supply, we can select the voltage here. Here we can set the engine speed. For example, if I change the engine speed to 3000 RPM, it will change the injection period. So now we're only pulsing the injector every 40 milliseconds. We can also set the pulse width. So 5 milliseconds, and you can see on the graph we've now got a 5 millisecond pulse width every 40 milliseconds. We can also set 2-stroke engines or 4-stroke or cycle engines. If I change the pulse width, you'll also see the duty cycle follows. So in this case, 20 milliseconds pulse width, and we have an injection period of 40 milliseconds. So the duty cycle is 50%, so the injector is on for 50% of the time. Likewise, I could enter a duty cycle figure and we'll see the pulse width changes accordingly. So 25% of 40 milliseconds period is a 10 milliseconds pulse width. In this section, we can select how long we're going to run the test for. At the moment, we're going to run the test for 300 injections. Equally, we could run for 30 seconds. To get accurate readings from the machine, we really need to fill the tubes as high as possible, somewhere between 100 and 130 cc's. If you know the maximum flow from the injector, you can use the estimate button to calculate this value for you. So if I click on the estimate button, I can enter the height in the flow tube that I want to reach, and hopefully I know the maximum flow from the injector, 500 cc's per minute. Click OK, and the program has calculated 1200 injections will fill the tube. So now to run a flow test, simply click on the green button and the test will run. You can stop it at any time using the red button, or it will stop on its own when it's reached the number of injections or filled the tube. I recommend always leaving this box ticked because it will allow the maximum duty cycle. With this ticked, the machine will flow test injector 1, then it will move on to flow testing injector 2, etc. If I untick this box, it will try and measure all flows together, and you are limited on duty cycle. So for example, I can probably only run up to about 23% duty cycle because this is injector 1 firing, this is injector 2 firing, 3 and 4, and they start to clash with each other if you set the duty cycle too high and the machine won't run. So always select sequential flow measurement. You will need machine firmware version 19.04 to do that. Here we can also select the type of test we want to perform. A flow test, which runs the pump and injector, a leak test, which runs the pump only, and a drain injectors test, which doesn't run the pump but fires the injector to drain them from fuel. Now let's have a look at how we can create injector data for engine tuners. So if we click on the injector data tab, it will reveal this screen. And here we have a button which will take you to the instructions. So here's a quick reminder about dead time and the effects of pressure and voltage on dead time. So here at the top we have a graph which will show the injector pulses in terms of voltage, the duty cycle, and the bottom graph shows the flow from the injector in cc's per minute against pulse width or duty cycle. We're testing the injector at 6,000 RPM, which means we're pulsing it every 20 milliseconds. We're running at 3 bar and 13.8 volts. And on the graph, we'll plot the flow against duty. And we'll also display the dead time here. Now first we're going to look at a perfect injector, which obviously doesn't exist. Now if I increase the pulse width or duty cycle, so here you can see we've now got a pulse width of 2 milliseconds every 20 milliseconds, and the dotted line shows the duty cycle, which is an average of the on time versus the off time. And as we can see, the injector flow starts increasing from 0 immediately as the pulse width increases. Now, if I continue to increase the pulse width and duty cycle, we can see that the flow increases too, all the way up to 100% duty cycle, which is the static flow value. Now let's also look at a real injector. So if I increase the pulse width again and the duty cycle, we can see a real injector follows a perfect injector, but it has this offset. So there's a delay between the pulse and the flow. So if we carry on increasing the duty up to 100%, we can see that both end up delivering 600 cc's per minute. Now, if I increase the pressure, you'll see that both flow and the dead time, which is currently 1.4 milliseconds, will increase. So the flow's now gone up to 1000 cc's per minute at 5 bar, and the dead time has increased to 3.2 milliseconds. And this is because it takes longer for the solenoid inside the injector to overcome the fuel pressure. Now let's have a look at battery voltage, or the voltage being supplied to the injector. Currently at 13.8 volts. Dead time is currently 3.2 milliseconds. So if I reduce the battery voltage, we can see that the dead time increases further. The remote control program allows you to measure dead time by firstly running a high flow test to get a point here, and then running a low flow test to get a point here somewhere. The program will then draw a straight line through those 2 points, and where that line crosses the x-axis, that's the dead time. So what does the engine ECU do with this dead time information? Well, in this example, for a perfect injector, if the ECU wanted 200 cc's per minute, it would have to pulse the injector for 4 milliseconds. For a real injector, to achieve 200 cc's per minute, it needs to pulse the injector for 8.2 milliseconds. That's the original 4 milliseconds plus the 4.2 milliseconds dead time. If you need some help with this process, click on the instructions button. If there's data in this table already, it can all be cleared using the clear button. Throughout this process, it's really important to fully drain the flow tubes. I recommend you drain the tubes for at least 30 seconds. Before running either the high flow or low flow tests, you need to make sure that the pressure is correct. This can be done by moving the injector to the spray position on the machine. Then you can select the high flow test, where you can enter how high you want the tubes to fill to and the approximate size of the injector. Then you can click on the start button to start the pump and injector. With the injector in the spray position, adjust the fuel pressure. In this case, we're setting it to exactly 3 bar. Now you can move the injector to the flow position and click on the green go button again. Here you can see the pressure has gone back to 3 bar exactly. And we wait for the test to finish. Here you can see there are effectively 2 levels of fuel, and it's important to read the bottom level. In this case, we have 115.2 cc's. So I'll enter 115 0.2 cc's into the high flow cc's box for injector number 1. Now we can repeat the whole process for the low flow test. Once again, we move the injector to the spray position and we adjust the fuel pressure to 3 bar. We wait for the test to end or we click the stop button. Now we place the injector in the flow position and click start again. Now, because we're running at a much lower flow, the test is going to take much longer to fill the tube to 100 cc's. For this test, we have exactly 115 cc's. So we can enter 115 cc's for the low flow test. Here you can see that the high flow test was much shorter than the low flow test in terms of number of injections. Here we can see the high flow is being calculated in terms of cc's per minute and the low flow in cc's per minute, and also the injector offset or dead time. Here we can also see the static flow or 100% duty flow and the pounds per hour. You can play with this screen without actually running a test just to see how it all works. For example, if I select the high flow and I were to type in some values into the high flow boxes, and then select low flow and type some values into the low flow boxes, we'll see that the program has calculated data for all of the injectors. This column shows the average for the 4 injectors, and this column shows the maximum variation from the average. All of the calculated flow results are shown for the vehicle fuel, for example, gasoline E5 to E10, but I can equally display flow rate values by clicking on the flow rate cell, and you will see that the flow values change by approximately 15%. Now we can save those results. We get this dialog. Enter a reference. This will be the result file name. File itself will have the date and time appended to the end of it, and some general information about the test. If you want to change the location of the result file, click on that box and select a folder. Click OK, and the results have been saved. If you want to view or print those results, click on this button. It will bring up a dialog of all your existing results, and you can locate the results file you've previously saved and load it by clicking on the OK button. Excel will load, and there we have the results, which can be printed from Excel in the normal way. You can also look at a graph of the results from here, and you can individually disable the results for each injector. That's all from me today. Thanks for watching.